August 15, 1940, RAF Tangmere, Southern England, 22:47 hours. The night sky was absolute black. No moon. Cloud cover at 8,000 feet. Perfect conditions for German bombers, Heinkels and Dorniers, to slip across the channel undetected, drop their payloads on British cities and disappear before dawn. RAF Fighter Command could do nothing. Spitfires and Hurricanes were day fighters, blind in darkness, dependent on visual contact to engage. Night after night, German bombers struck with impunity while British fighters sat grounded, useless listening to the distant explosions. But on this night, something changed. Flight Lieutenant John Cunningham taxied his Hurricane to the runway. His aircraft looked different. Cables protruded from the nose. Strange aerials extended from the wings. The ground crew had nicknamed it Frankenstein's Fighter, a Hawker Hurricane modified by a civilian electrician named Eddie Bowen with equipment that shouldn't work. Air intercept radar, AI Mark IV, 8 experimental units installed in converted Hurricanes, untested in combat, untrusted by pilots, dismissed by most RAF commanders as pipe dreams and copper wire. But tonight, Cunningham would prove them all wrong. At 23:14, his radar detected a contact. At 23:22, he fired. And the Heinkel He-111 fell burning from the darkness. The era of night fighting had begun. To understand how an electrician changed aerial warfare, you need to go back to 1935, when a young Welsh physicist named Eddie Bowen joined a secret research team at Bawdsey Manor, Suffolk. Britain was rearming. War with Germany seemed inevitable. The RAF had one critical vulnerability. They couldn't detect incoming bombers until observers saw them visually. By then, it was too late. A scientist named Robert Watson Watt proposed a solution: radio direction finding, later called radar, radio detection and ranging. The concept was simple: transmit radio waves, detect what bounces back. If something reflects the signal, something's there. The team built the first chain home stations, massive radar towers along Britain's coast. They could detect bomber formations 100 miles away. It was revolutionary. It would save Britain during the Battle of Britain. But there was a problem. Chain home could tell you bombers were coming. It couldn't help you shoot them down at night. Fighters needed their own radar, small enough to fit in an aircraft, powerful enough to detect bombers at useful range, precise enough to guide pilots to within visual distance. It seemed impossible. Radar sets weighed tons, required massive antennas, consumed enormous power. How could you miniaturize that into something a Hurricane could carry? Eddie Bowen, not a military officer, not even a proper engineer, just a brilliant electrician with an intuition for how radio waves behaved, said, "Give me 6 months." His supervisor laughed. "Eddie, the best minds in physics have been working on this. What makes you think an electrician can solve it?" Bowen's answer was characteristically blunt. "Because I'm not trying to build perfect. I'm trying to build good enough." He started with a simple premise. You don't need to detect a bomber at 100 miles. You need to detect it at 2 miles. Close enough for a pilot to close in and acquire visual contact. Shorter range meant less power. Less power meant smaller equipment. Smaller equipment meant it could fit in a fighter. The theory was sound. The execution was nightmarish. Bowen spent 18 months in a workshop, winding copper wire around ceramic forms, building transmitters and receivers by hand, testing, failing, rebuilding. His hands were scarred from electrical burns. His eyes strained from examining oscilloscope traces for hours. But by July 1940, as the Battle of Britain raged, he had a prototype, AI Mark IV, 40 pounds, mounted in the nose of a Hurricane. Effective range, 3 miles. Now he just needed to convince the RAF to use it. The RAF was skeptical, deeply, institutionally skeptical. Wing Commander Basil Embry, head of Fighter Command's night operations, examined Bowen's radar set and said flatly, "This is a box of copper wire and hope. My pilots are fighting for their lives. I won't send them up with experimental nonsense that might fail at the critical moment." Bowen understood the resistance. Pilots were conservative. They trusted their eyes, their instincts, their aircraft. Adding an untested black box that beeped and showed blips on a tiny cathode ray screen felt like witchcraft. But the night bombing was getting worse. In August 1940 alone, German bombers struck British cities 73 times at night. RAF night fighters, flying blind, relying on luck and searchlight cooperation, shot down exactly 4 German bombers. 4, out of hundreds. The mathematics were unsustainable. Bowen went over Embry's head. He demonstrated the AI Mark IV to Air Vice Marshal Sholto Douglas, who saw what Embry couldn't. Desperation required risk. Install 8 units, Douglas ordered. Find 8 pilots willing to test them. If it works, we expand production. If it fails, he didn't finish the sentence. Finding pilots was harder than building the radar. Most fighter pilots were young, aggressive, visual hunters. They'd trained to dogfight in daylight, eyes scanning sky for enemy silhouettes. The idea of staring at a green screen, trusting electronic blips, felt unnatural. But John Cunningham, a 23-year-old Hurricane pilot from Croydon, volunteered immediately. Cunningham was different from typical RAF fighters. He'd been an engineering student before the war. He understood electronics. More importantly, he understood that war required adaptation. "I don't need to understand how it works perfectly," he told Bowen during training. "I need to understand it well enough to use it." Bowen spent 2 weeks teaching Cunningham to interpret the radar display. The screen showed range and azimuth, distance and direction. A blip appeared when the radar detected something. As you closed in, the blip moved. Your job: adjust heading to center the blip. Close to minimum range, then look up and acquire visual contact. Simple in theory, extraordinarily difficult in practice. On August 15th, Cunningham flew his first operational sortie with AI Mark IV. Ground controllers vectored him toward a German bomber formation. His radar operator, a young sergeant named Philipson, called out contacts. Blip, at 2 miles. 11 o'clock. Cunningham adjusted heading. The blip centered. 1 mile. Closing. Cunningham strained his eyes into darkness. And there, barely visible against clouds, a Heinkel, He-111. He fired. The bomber exploded. Britain's first radar-assisted night kill. The success of Cunningham's kill rippled through fighter command like an electric shock. Within 48 hours, every senior RAF officer wanted a briefing on AI Mark IV. Douglas pushed for immediate expansion. Install the system in 50 Hurricanes, train 50 crews, deploy them across southern England. But production couldn't keep up. Bowen's radar sets were hand-built. Each unit required 60 hours of meticulous assembly, winding copper coils, calibrating transmitters, testing receivers. Britain's electronics industry was already stretched building chain home stations and naval radar. There was no capacity for mass production. Bowen worked 20-hour days. He trained technicians to replicate his assembly process. He simplified designs, cut corners where possible without compromising performance. By September, production reached 4 units per week. It wasn't enough. German night bombing intensified. The Blitz began. London bombed 57 consecutive nights. Coventry devastated. Liverpool, Manchester, Birmingham all hit repeatedly. Thousands of civilians died, tens of thousands injured, and the RAF still had only 12 AI-equipped night fighters operational. The public didn't know about the radar. Censorship kept Bowen's invention secret. Revealing AI capabilities would alert Germans to develop countermeasures. So newspapers credited night fighter successes to cat-eyed pilots with exceptional night vision. They even published propaganda suggesting RAF pilots ate carrots to improve their eyesight, a deliberate misdirection to hide the real secret: copper wire and radio waves. Cunningham became the public face of this deception. Newspapers called him Cat's Eyes Cunningham, Britain's greatest night fighter ace. He played along, never mentioning radar in interviews, but privately, in reports to Fighter Command, Cunningham pushed hard for more AI-equipped aircraft. "Every night I intercept 1, maybe 2 bombers," he wrote, "but there are dozens more I never find. We need 50 night fighters with AI, 100. The technology works. We just need more of it." The breakthrough came in October 1940 when the Ministry of Aircraft Production allocated emergency resources to AI radar production. Factories in Birmingham and Manchester began producing standardized components. Assembly time dropped from 60 hours to 20. By December 1940, 75 AI-equipped night fighters were operational. By March 1941, 150, and German bomber losses at night, which had been negligible, began to climb. 4 in August, 7 in September, 15 in October, 32 in November. The Germans noticed, and they began to wonder, what changed? In German bomber squadrons, a new fear emerged: the invisible hunters. Luftwaffe crews had grown comfortable with night operations, British fighters couldn't see in the dark. British anti-aircraft fire was inaccurate. You flew to target, dropped bombs, flew home. Routine. Safe. But suddenly, bombers were being intercepted in total darkness. No searchlights, no visible pursuit. Just sudden cannon fire from behind, and a Heinkel or Dornier falling in flames. One German pilot captured after his bomber was shot down in November 1940 told interrogators, "We didn't see him. We didn't hear him. The first indication was bullets hitting our aircraft." How is this possible? Do British pilots have cat eyes? British intelligence encouraged this belief. They leaked false information suggesting RAF pilots underwent special training to enhance night vision, that they ate special diets, that they were selected for genetic visual superiority. The truth, AI radar, remained classified. But the psychological effect was real. German bomber crews grew paranoid. They flew higher, faster, took evasive action randomly. Bomb accuracy dropped. Mission effectiveness decreased. More importantly, morale collapsed. A Luftwaffe bomber pilot's diary captured in 1941 recorded, "We are hunting ghosts. Every shadow could be a British fighter. Every sound, enemy engines. We cannot see them, but they see us. This is not combat. This is slaughter." By spring 1941, German bomber losses over Britain exceeded sustainability. The Blitz continued, but with diminishing intensity. By May 1941, it effectively ended, not because Germany stopped wanting to bomb Britain, but because the losses were unacceptable. AI radar hadn't won the Battle of Britain. Spitfires and Hurricanes did that in daylight, but AI radar won the night. And in winning the night, it made strategic bombing of Britain too costly to continue. Meanwhile, Eddie Bowen remained in his workshop, unknown to the public, obsessively improving his invention, AI Mark V, Mark VI, Mark VII. Each iteration lighter, more accurate, more reliable. By 1942, British night fighters dominated European skies so thoroughly that German bombers rarely attempted night operations over Britain. Bowen never received public recognition during the war. His work was too secret. The public credited pilots like Cunningham, not the electrician who gave them eyes in darkness, but in fighter command, everyone knew the truth. One officer wrote in a report, "We talk about aces, about bravery, about skill, but none of it matters without Bowen's black box. He didn't fly, he didn't fight, but he won the night." The carrot myth became one of the most successful propaganda campaigns of the war. British newspapers ran stories about RAF pilots' exceptional night vision. Doctors gave interviews about vitamin A and retinal sensitivity. The Ministry of Food published recipes for carrot-based meals to help you see like an RAF pilot. It was complete fabrication, but it served two purposes. First, misdirection. If Germans believed British night fighter success came from biology, they wouldn't look for technology. Protecting AI radar's secrecy was paramount. Second, morale. British civilians, enduring nightly bombing, needed to believe their defenders had an advantage. Cat-eyed pilots provided that reassurance. John Cunningham played his role perfectly. In interviews, he spoke vaguely about good night vision and training. He never mentioned radar. When asked about his success, he deflected. It's teamwork. Ground controllers, searchlight crews, anti-aircraft batteries, everyone working together. But among pilots, resentment grew. Night fighter crews knew the truth. AI radar made them effective, yet public credit went to propaganda myths. One pilot wrote bitterly in his diary, "We're fighting with 1940s technology disguised as 1840s biology. Bowen should get the medals, not us. We're just the ones pushing the buttons he designed." Cunningham disagreed. In a rare moment of candor with a fellow pilot, he said, "The radar finds them, but we still have to kill them. The technology doesn't pull the trigger. We do. And that takes something the black box can't provide. Courage." In Germany, intelligence services suspected the carrot story was cover for something. But what? They didn't know about radar miniaturization. German radar technology lagged Britain's by 2 years. The idea that you could fit detection equipment in a fighter seemed absurd. One German intelligence report from 1941 concluded, "British night fighter improvements likely result from superior training and tactics. No evidence of new technology." It was exactly what British intelligence wanted them to believe. The deception held until 1943, when a British bomber carrying advanced radar was shot down over Holland intact. Germans recovered the equipment and finally understood what they'd been fighting. By then, it was too late. Britain had 2-year head start in AI radar development. Germany scrambled to catch up but never did. The night belonged to Britain, and Britain's night hunters, guided by an electrician's copper wire modifications, ruled the darkness absolutely. Eddie Bowen never spoke publicly about the emotional cost of his invention. He worked 18-hour days, 7 days a week for 2 years straight, from 1939 to 1941. His marriage strained. His health deteriorated. He developed chronic insomnia, his mind racing with design improvements even when he tried to sleep. His colleagues noticed the toll. One researcher wrote, "Eddie is obsessed, not in a healthy way. He takes every bomber that gets through as a personal failure. Every British casualty. He blames himself for not working faster, not building more units, not making the radar better." In December 1940, a German bomb hit Bowen's neighborhood in London. His house was undamaged, but his neighbor's family, parents and 3 children, died in the blast. Bowen arrived at the workshop the next morning with red eyes and shaking hands. Colleagues suggested he take time off. He refused. "How many hours until the next unit is finished?" he asked. 18, maybe 20. "Make it 12. We're cutting assembly time." He pushed his team mercilessly. Some resented him. Others understood. This wasn't cruelty, it was desperation. Every hour saved in production meant one more night fighter operational, one more bomber intercepted, one more family that might survive. But the weight was crushing him. In January 1941, his supervisor found him in the workshop at 3 a.m., sitting alone in darkness, staring at a disassembled radar unit. "Eddie, go home." Bowen didn't look up. "Do you know how many bombers got through tonight?" "No." 7. 7 made it to London. We had 5 AI fighters up. They got 2 intercepts, 1 kill. That means 6 bombers dropped their loads unopposed. "Eddie, you can't." Each bomber carries 2,000 pounds of explosives. That's 12,000 pounds of bombs on British civilians tonight. Because I haven't built enough units. Because the radar isn't good enough yet. Because I'm not working fast enough. His supervisor sat beside him. "You've saved thousands of lives, you know that, right?" "I know I haven't saved enough." The supervisor had no answer to that. By spring 1941, as AI radar production finally ramped up and German bombing decreased, Bowen's obsession eased slightly. But the weight never fully lifted. For the rest of his life, he carried the knowledge. His invention killed. His radar guided fighters to German bombers, and young German airmen died in flames because of his copper wire modifications. He saved British lives. He took German lives, and he was haunted by both. By mid-1941, AI radar had evolved from experimental technology to operational doctrine. Fighter Command established dedicated night fighter squadrons, 85 Squadron, 29 Squadron, 604 Squadron, equipped entirely with radar-fitted Beaufighters and Mosquitoes. The Hurricane proved too slow for night interception. Newer, faster aircraft took over. Cunningham transitioned to the Mosquito, a wooden wonder that combined speed, maneuverability, and the space to carry improved AI Mark VIII radar. His kill count climbed, 20 confirmed by end of 1941, making him Britain's top night fighter ace. But the war was changing. Germany invaded Soviet Union in June 1941. Luftwaffe bombers shifted east. Night bombing of Britain decreased dramatically. RAF night fighters needed new missions. The answer? Intruder operations. Instead of waiting for German bombers to come to Britain, AI-equipped fighters would go to Germany. They'd loiter near Luftwaffe airfields at night, waiting for bombers to take off or land. When they were most vulnerable, slow, low, unable to maneuver, it was extraordinarily dangerous. Deep penetration into German airspace. No friendly ground control. If shot down, certain capture or death, but it was devastatingly effective. Cunningham flew his first intruder mission in August 1941, targeting a German bomber base near Eindhoven, Holland. His AI radar detected a Junkers Ju-88 on final approach, landing lights on, gear down, defenseless. He shot it down. The German crew never knew what hit them. Over the next year, intruder operations destroyed hundreds of German aircraft, not in dramatic dogfights, but in one-sided ambushes. German bomber crews called British night fighters mosquitoes of death, unseen, unheard until cannon fire tore through their aircraft. The psychological impact on Luftwaffe morale was immense. Airfields that should have been safe havens became death traps. Pilots grew paranoid about night takeoffs and landings. Operational tempo decreased as squadrons implemented elaborate security procedures, reducing sortie rates. Meanwhile, Bowen continued improving AI radar. Mark VIII featured better range and accuracy. Mark IX added automatic tracking. Mark X, developed in collaboration with American engineers, used centimetric wavelengths, dramatically improving resolution. By 1943, British night fighters could detect, track, and kill enemy aircraft in total darkness with near certainty. The technology that started as copper wire and hope had become the most sophisticated airborne sensor system in the world. Germany tried to develop countermeasures. They installed rear warning radar in bombers. They trained crews in evasive tactics. They even developed their own airborne intercept radar, but they were always 2 years behind. And in technological warfare, 2 years is an eternity. In November 1942, Eddie Bowen received an unusual visitor, an American colonel from the U.S. Army Air Forces. "Mr. Bowen, I'm Colonel Harold Martin. I've been sent by General Arnold to discuss technology transfer." America had entered the war in December 1941. Now, a year later, U.S. bombers were beginning daylight raids over Germany. But they'd need night operations too, and American airborne radar lagged Britain's by 18 months. "We want to license your AI technology," Martin said bluntly. "We'll manufacture it in the States, install it in our night fighters. What do you need from us?" Bowen thought for a moment. "Cavity magnetrons." Martin blinked. "Excuse me? Your engineers at MIT Radiation Lab developed high-power cavity magnetrons. We've heard rumors, classified of course, but if the rumors are true, your magnetrons generate 10 times the power of our klystrons. That power would let us build radar with 5 times the range." Martin smiled. "I can neither confirm nor deny. Colonel, let's not waste time. You want our AI expertise, I want your magnetron technology. Do we have a deal?" They shook hands. Over the next year, Anglo-American radar cooperation became one of the most successful technology partnerships of the war. British AI techniques combined with American manufacturing scale and component technology created radar systems that dominated night skies over Europe. American P-61 Black Widows and British Mosquitoes, both carrying advanced AI radar, hunted German aircraft relentlessly. By 1944, Germany effectively conceded the night. Their bombers stopped flying. Their night fighters withdrew to defensive positions. The technology that one electrician developed in a British workshop now equipped thousands of Allied aircraft. But for Bowen, the expansion brought new anxieties. American engineers wanted to simplify his designs for mass production. They proposed changes that would reduce performance slightly, but increase reliability and ease of manufacturing. Bowen resisted. Every meter of range lost could mean a missed intercept, a bomber that gets through. The Americans argued, every hour saved in production means one more radar built, one more fighter equipped. The math favors quantity over perfection. Bowen struggled with this logic. His instinct was always toward optimization, making each unit better. But they were right. Sometimes good enough mass-produced beats perfect and scarce. He agreed to the simplified design. By May 1944, D-Day minus 1 month, over 2,000 Allied aircraft carried AI radar. German night operations had essentially ceased. One electrician's copper wire modification had changed the war. Imperial War Museum, London. Eddie Bowen stood before an exhibit featuring a restored Mosquito night fighter. Inside the aircraft, mounted in the nose, was an AI Mark VIII radar set, one of his designs from 1942. A young museum curator approached. "Mr. Bowen, I'm Sarah Mitchell. I wanted to thank you for coming to the opening." Bowen, now 63, retired from academia, looked at the radar set behind glass. "Strange seeing my work in a museum. Makes me feel ancient." Sarah smiled. "You changed aerial warfare. This exhibit is meant to honor that. I built a box that detected radio waves. Pilots did the actual fighting, but without your box, they'd have been helpless." Bowen considered this. 27 years since he'd wound copper wire around ceramic forms by hand. 27 years since desperate 18-hour days trying to give RAF night fighters a chance. "Can I ask you something?" Sarah said. "The records show you suffered a breakdown in 1945, after the war ended. Can you talk about that?" Bowen was quiet for a long moment. "For 6 years, he finally said, I worked under the belief that every hour I wasted, people died. Every design flaw, every production delay, measured in lives lost. That kind of pressure doesn't turn off just because the war ends. What happened? I collapsed. Exhaustion, stress, accumulated trauma. Spent 3 months in hospital. Took another year before I could work again. And even now, 20+ years later, I wake up sometimes at 3 a.m. thinking, did I work fast enough? Could I have saved more people? Sarah touched his arm gently. Mr. Bowen, historians estimate AI radar saved tens of thousands of British lives. Maybe more. You did enough. Bowen looked at her. Did I? Because I also helped kill tens of thousands of German airmen. Young men who were just following orders, just trying to survive. My radar guided British fighters to them. They died in flames because I made a better radar. You were at war. They were trying to kill your people. I know. Rationally, I know. But rationality doesn't erase the weight. He turned back to the exhibit. You want to honor me? Honor all of them. The British pilots who used my equipment. The German airmen who died because of it. Honor the civilians my radar saved. And honor the moral complexity of building weapons, even for defensive purposes. Sarah nodded. We will, I promise. Bowen smiled sadly. Good. Because war isn't simple, and the people who change it, we're not heroes. We're just people who made choices under impossible pressure. The deeper significance of AI radar wasn't technical, it was perceptual. For millennia, night was a sanctuary, darkness protected. Armies didn't fight at night because they couldn't see each other. Night bombing worked because defenders were blind. AI radar shattered that sanctuary. Suddenly, darkness offered no protection. The invisible became visible. The safe became dangerous. This changed warfare fundamentally. Before AI radar, night bombing was a viable strategy. After AI radar, it became suicide. This shift forced Germany to abandon strategic bombing of Britain, not because they lacked bombers or pilots, but because the night no longer protected them. One German general, in post-war memoirs, wrote, "We lost the night before we lost the war. Once British fighters could find us in darkness, our strategic position became untenable. We couldn't destroy British industry. We couldn't break British morale, and we knew, eventually, we would lose." But the perception shift went beyond tactics. It changed how humanity thought about technology. AI radar proved that science could extend human senses. You couldn't see at night, but a machine could see using radio waves. This concept, using technology to perceive beyond natural human limits, became foundational to modern warfare. Today, every military aircraft carries descendants of Bowen's copper wire modifications. Radar, infrared sensors, synthetic aperture imaging, electromagnetic detection, all extensions of the same principle, use technology to perceive what humans cannot. But there's a darker element to this perception shift. When night was safe, there were natural limits to warfare's intensity. Combatants had to rest. Civilians had nighttime respite from bombing. Darkness enforced a rhythm. Fight during day, recover at night. AI radar eliminated that rhythm. Suddenly, war could be continuous. 24-hour operations became possible. The tempo of violence intensified. A British historian wrote, Bowen's invention saved Britain, but it also made modern warfare more total, more unrelenting. Before AI radar, war had pauses. After, war became constant. Whether that's progress is debatable. Bowen himself wrestled with this paradox until his death in 1991. In his final interview, he said, "I'm proud I helped save Britain. I'm troubled by what my invention enabled. Technology is neutral. It amplifies human intent, whether protective or destructive. I intended protection, but I created a tool that made continuous warfare possible, and I'm not sure I can morally untangle those two outcomes. That ambiguity, the simultaneity of salvation and destruction, defines Bowen's legacy." In 1985, Eddie Bowen was invited to give a lecture at Cambridge on the ethics of weapons development. He was 71, frail, but mentally sharp. The auditorium was packed. Students, professors, veterans, engineers, all wanted to hear from the man who changed aerial warfare. Bowen stood at the podium, silent for a moment, then began. "I'm going to tell you something I've never publicly admitted. In 1940, when I built the first AI radar set, I believed I was building a defensive weapon, something to protect Britain from bombers. Pure defense, morally uncomplicated. But weapons are never purely defensive. Every defensive weapon becomes offensive in different hands. My AI radar protected British cities, but it also guided British fighters deep into German airspace, killing German airmen over their own homeland. Defense became offense seamlessly. After the war, I learned that Germany never developed effective AI radar. Know why? Because they were winning in 1940. They didn't need it. Only the desperate innovate. I was desperate. Britain was desperate. So I innovated. And my innovation, born from desperation and survival instinct, killed thousands of young German men who were as scared and desperate as I was. People call me a hero. I don't feel like one. I feel like a man who made a tool, and that tool was used to kill. Yes, it saved British lives. Yes, Britain's survival was morally justified. But the German boys my radar helped kill, they had mothers too. They had lives too. So here's my question to you, future engineers, future scientists, future inventors. How do you live with that? How do you build something that saves your people by killing other people? How do you calculate that moral mathematics? I don't have an answer. I've lived with this for 45 years and I still don't have an answer. What I do know is this. Don't build weapons and pretend they're neutral. Don't invent something that kills and tell yourself it's just defense. Own the full consequence if you build a weapon, even a defensive one. Accept that you're responsible for every life it takes as well as every life it saves. Can you live with that? Because I have to. Every day. And some days, it's very hard. The auditorium was silent. Then, slowly, a student in the back stood and began clapping. Others joined. Within seconds, the entire room was applauding, not celebrating, honoring honesty, honoring the courage it took to speak moral ambiguity out loud. Bowen stood at the podium, tears streaming down his face, accepting applause he wasn't sure he deserved. Today, Eddie Bowen's name appears in specialized histories of radar development, but rarely in popular accounts of World War II. John Cunningham, Cat's Eyes Cunningham, remained the public face of British night fighting until his death in 2002. He flew 21 confirmed kills, became a test pilot after the war, never took credit he felt belonged to engineers like Bowen. In a 1995 interview, Cunningham said, "People remember pilots. We're visible, dramatic. But the real heroes of the night war were people like Eddie Bowen, working in workshops, building tools we didn't even understand fully. I pressed buttons and pulled triggers. He built the system that told me where to aim." Bowen himself never achieved public recognition comparable to radar pioneers like Watson Watt or inventors like Barnes Wallis. His work was too classified during the war, too technical afterward. He died in 1991, age 77, quietly, in Wales. His obituary in the Times was 4 paragraphs. The headline read, "Radar Pioneer Dies." But in military museums worldwide, AI radar units sit in exhibits, explained by plaques that say, "This technology changed aerial warfare." It gave defenders the ability to see in darkness. It ended German strategic bombing of Britain. It saved countless lives. They rarely mention Eddie Bowen by name. In 2015, a historian named James Davies published a comprehensive biography, The Electrician Who Won the Night. It detailed Bowen's contributions, his obsessive work ethic, his post-war struggles with moral weight, his death in relative obscurity. The book sparked renewed interest. Veterans organizations petitioned for Bowen to receive posthumous honors. In 2018, a memorial plaque was installed at Bawdsey Manor, where Bowen developed AI radar. It reads, "Edward George Bowen, 1911-1991, physicist and engineer. His airborne radar systems transformed night warfare and saved Britain during its darkest hour. I built what was needed, when it was needed, as best I could." That last quote, from a 1987 interview, captures Bowen's entire philosophy. No claims of genius. No demands for glory. Just I did the work that needed doing. Perhaps that's the most important legacy. Not the technical achievement, though that was extraordinary. Not the strategic impact, though that was war-changing. But the example, when your people are desperate, you build what they need. You do it quickly. You do it well. You accept the moral weight. And you don't demand applause. You just do the work.